All right, so this is lesson 6-4, gang. And what we're going to be doing is we're going to be looking for common denominators. To find a common denominator, we need to know that the denominator is going to be the bottom part of any fraction. So this is your denominator, and that's the number of pieces that you're working with in total. The numerator is the number on top of a fraction, and that's how many pieces you have that will be shaded in when you're drawing a picture. Okay? We're going to be given two different fractions that are going to be cut in different sizes, like the ones you see here. Martin has these two rectangles. This one is cut into 2 halves, and then this one is cut into thirds. And what we want to do is he wants to cut it or to shade it so that the rectangles will then have the same sized parts. Because you can see on this half that that's a lot more space than one of these thirds. It's a much bigger slice. So we can't compare them or add them unless they are the same size denominator, same pieces. So what we're going to do is that's called finding a common denominator. And that's what we're working on. So we have these rectangles and they're folded, and we need a common denominator for the 2 and the 3. And we do that. So here they're going to show that they can fold it, and we're not going to be folding our paper. And you could fold paper at home, but I'm going to show you what happens after we're done folding. So what I have is I have the fraction 1/2, and I have the fraction 1/3, and I need to have the same denominator. So what I'm going to do is I'm going to use my multiples skill. I'm going to count by 2s. I'm going to do 4 or 5 of them. And then I'm going to count by 3s. And I'm going to take the first multiple. Multiples go higher, higher. Multiply, multiples go higher, go higher. You know you're singing that with me, right? Okay, let me go back and fix this. So what I have here is if I cut these or fold these rectangles so that they each have 6 pieces, that's that common denominator. I put it in the denominator spot. ND, denominator is the bottom. Now I'm going to cut this so that I have 6 pieces for each of the rectangles. Well, to do that, this first one means that I'm going to create 3 new pieces, or I'm going to triple the size. And if I'm going to take the denominator and triple it, I also have to triple the numerator and times it by 3, so that now I have 3 out of 6 shaded in, since I now have this in 6. See it? 3 out of 6 pieces. Now I didn't change how much I was shading. I just cut it so that we would have equal sizes to compare. I'm going to do that same thing on the thirds, only I have to think, well, if I've got 3 pieces, how am I going to turn it into 6 pieces? And I'm going to double it, so I'm going to times it by 2. And if I'm going to multiply the denominator by 2, then I also have to multiply the numerator by 2. Well, in a picture, when I cut this and now I have 6 pieces on this rectangle as well, I can see that I end up with 2 out of 6. I didn't change how much was shaded. It's still the same size as 1/2 and 1/3, takes up the same amount of space. My dog's agreeing with me. Thank you, Allie. So she's not gonna stop. So now I can see that if I wanted to add them together, they're the same sizes. If I wanted to compare them, they're also equal sizes. And I did that by getting a common denominator. And I can see that 1/2 takes up more space than 1/3, so it's going to be the larger of the 2 fractions. All right, so we will be comparing the sum in some of these. All right, let's go to the next one. So turn the page, and this kind of walks you through the process again. On this next page, we have 2 different fractions that we're looking at. We're looking at 4/5 and 1/2. And again, we want to have a common denominator because 4/5 and 1/2 are, the pieces are not the same size. Our step that we're going to do is we're going to create a common multiple. So we need to find our multiples of both 5 and 2. We're going to find the multiples of our denominator. And then what happens is we rename them. And you can see that in step 2, it set that up. We're going to rename 4/5 and we're going to rename 1/2. So in your Go Math assignment, you're going to have to take this, you're going to do this part on paper, but this is the part right here that you're going to enter into the computer as your final answer. So what did you get when you took 4/5 and turned it to tenths? You're going to skip this as your work area. Now you're still going to do that. You're just not going to put it into your answer or into the solution. So let me just erase that. Okay, so we have 5s, and we're going to find the multiples of 5. So finish it out. 5, 10, 15, 20, 25, 30. How do you know when to stop? I do 4 or 5. If I find a match, then I'm done. If I don't find a match within the first 4 or 5 multiples, then I have to keep going. And that's, so 2, 4, 6, 8, 10. And immediately, I can stop at 10. I could fill in the next one. I see that I have a common multiple. That's now my denominator. It's now my new bottom part of my fraction. So in that 4/5, and they just kind of rewrote it here, 4/5 needs to change to tenths. Well, when we're always either going bigger, we're multiplying, or we're going to be simplifying a fraction like we did last week where we divide. It's always either multiply or divide those parts. How do I go from 5 to 10? I double it, so I'm timesing by 2. Whatever I do to the bottom part of a fraction, I do to the numerator, the top part of the fraction. That's what keeps it balanced and equal. So now I have 4 times 2 is 8. So the fraction 4/5 is the exact same size as the fraction 8/10. They're equal. 1/2 also changes to tenths. So what did I do to 2 to get it to a 10? I multiplied it by 5. Whatever I do to the bottom part of that fraction, I'm going to do to the numerator, the top part. So that 1/2 shows that it's equivalent to 5/10. So then in the computer, Go Math is going to have it kind of written like this. You're going to do this part on paper, and then you're going to have to fill in the boxes on Go Math. And you're going to click in the box, and you're going to put in the little fraction box. So 4/5 is the same as 8/10. I'm going to do them in order. And 1/2 was equal to, or the same as, 5/10. And that's how I answer it within the computer. So the question down below says, so are 4/5 and 1/2 equal to each other? Are the exact same size? And the answer to that is no. 8/10 is bigger than 5/10. So no, 4/5 and 1/2 are not equivalent. 4/5 is what, guys? Is it the smaller one or the larger one? Is it better to have 8 or 5? Well, you'd rather have 8 out of 10. If it was a test score, that would mean you score higher. 4/5 is greater than, get in that good math vocabulary, greater than 1/2. Notice how on this particular thing, I had to go back and explain it using the fractions they gave it to me in. So even though I used the 8/10 and the 5/10 to think about my answer, I wrote my actual answer using these fractions, the fractions that I started with, because that's what the question asked me to use. Okay, let's go down to the model and look at that, because it's showing you that picture. Again, you're finding a common denominator. Common denominator is the same thing as finding a common multiple. And we have been doing that for weeks. All right. So we have 1/3 and 1/12. They're not cut the same size. One is cut in 3 pieces and one is cut in a 12. So what we want to do is we want to take 3 and then we want to take 12 and we want to find some multiples. So off to the top there, 3, 6, 9, 12. Okay, now I can actually stop because 3 skip counts up to 12, and 12 is the other number. So I don't even have to do 12, 24, 36 because these are already my least common multiple or my common match. So what I'm going to do then, it wants to know what's the common denominator here. So my common denominator is going to be 12. I'm going to turn these into 12 pieces. Now this one's already in 12s. There's nothing for me to change. I can just leave it right like that. So for me to change this to 12s, I'm going to have to go bigger. I'm going to have to multiply by 4. Whenever I do the bottom, I'm going to do the top of the fraction, so that's going to be 4 12ths. So when I draw it, I'm cutting it to four more larger chunks, and you can see that 1/3 is equal to 4 12ths. Now they're easy to compare, and I can tell that 1/3 is larger than 1 12th. Okay? All right, so let's keep going. Let's keep thinking about it. Go to the next page. The top, we're going to do some of these together. And the directions want us to know, write the pair of fractions as a pair of fractions with a common denominator. And that's exactly what your Go Math assignment's going to do. All right, so you want the common denominator, and you're going to want 2 new fractions. You're going to want a new fraction for 1/2, and you're going to want a new fraction for 1/4. Well, to do that, you need to find your common denominator. So count by 2s. 2, 4. Oh, I can keep going. 6, 8. The other denominator, I'm going to count by 4s. And see it? Now, 8 is also a common multiple. I could actually use either one. I always like to use the smallest. Okay? We call that, as we get older, our least common denominator. So I'm changing 1/2, and I'm changing it, I'm going to go with the 4, remember, and I'm changing the denominator for both of these to 4ths. So how do I go from 1/2 to 4ths? Well, what do you multiply 2? 2 times 2 is 4, so 1 times 2 is 2. So 1/2 changes to 2/4. This is already in 4ths. So I'm just going to rewrite it down. 2/4, 1/4. That's what I'm renaming. We're going to do the same thing with 3. I'm going to find a common denominator for 4 and 8. And then I'm going to rename those fractions. So 3/4 and 5/8 is going to go in that box. Count by 4s. 4, 8, 12. You saw it, didn't you? I don't have to go any bigger because theirs is their common multiple. That's what they share. So my new denominator is going to be 8 for both fractions. And you saw it, didn't you? This one is already 8s. I don't have to change a thing. I'm just going to rewrite that over into my answer box. 3/4, though, I need to change 3/4 into 8s. So how do I go? Again, I'm going bigger, so I'm multiplying. 4 times 2 is 8, so 3 times 2 is 6, equivalent fractions. And then I can also compare them here. 6/8 is bigger than 5/8, so I know that 3/4 is the larger of those fractions. Getting it? All right, let's keep going. All right, we used up the space for number 4, so let's come over here to number 5. Again, I want the common denominator of 12 and 8, and I'm going to be renaming and making 2 new fractions. Kind of set up my thinking. Pause whenever you need to. And let's skip count by 12s. 12, 24, 36, 48. And I do a couple. Let's do 8s and see if we get a match. 8, 16, 24. As soon as I get a match, I stop. I don't need to keep going. So my least common denominator is going to be 24. Now I'm going to be able to cut them into the same sizes. And none of my original fractions were in 24ths. So I'm going to rename, that's what we call it, we're renaming it. We're changing 4/12ths into how many 24ths? How did we go from 12 to 24? What did we multiply by? Yep, we multiplied by 2. So 12 times 2 is 24. 4 times 2 is 8. So those fractions are equivalent. 5/8 is equal to how many 24ths? So 8 times 3 is 24. That means 5 times, 3 is 15. And now I have done what my directions said, which is write a pair of fractions as a pair of fractions with a common denominator. So now I've changed and renamed them to where they're cut to the same size pieces, and they're all these little 24ths. All right, so let's look what down here. Write the pair of fractions as a pair of fractions with a common denominator. So same thing, didn't change directions, it just wants us to try it again. So again, 4ths and 6s. I'm going to count by 4, I'm going to count by 6. The first number I land on is going to be my new denominator. 4, 8, 12, 16, 20. Do a couple. Now do my 6s. 6, 12. I'm done. I have a match. Ding, 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 ding. 12's my match. 12 is my new denominator. Okay? So remember, I'm changing 1/4 into 12ths. Well, what did I do to 4 to make it 12? 4 times 3 was 12. 1 times 3 is 3. So 1/4 is the same as 3/12. Let's see how many 5/6s go into 12. So again, I'm comparing, how did I go from 6 to 12? Times 2. Whenever I do the bottom, I do the top. And now I have the new fractions that have a common denominator. All right, one more. Why don't you pause this one and try to do it and then come back and check it. Get your common denominator. Count by 5s, 5, 10. Oh, there's my match, done. So I'm renaming these fractions, and I'm going to have a denominator of 10. Notice that I'm always going in order from left to right. So 3/5 is equal to how many tenths? Well, 5 times 2 is 10, so 3 times 2 is 6. That's the answer for this one. And now I'm renaming 4/10. Oh wait, it's already tenths, so I'm not changing anything. It is what it is, it's 4/10. Didn't have to change it. Totally missed that. Okay, so how'd you do? Very good. Now the next part is you are given two fractions and you want to know if they're equal. So this is how I write equal, and you've been doing that. This symbol means not equal. So if I write an equal sign with a line through it, it means nope, they are not equal to each other. And there's a pretty easy way to do it when you have different denominators. I could do all the steps above, or I could just look at the smaller one. Is there anything I can do to 2 to make it 4? Well, I can times by 2. Well, if these guys are equal, and I multiply this by 2, that would be a 2, and it's not. So that tells me that 3/4 is not equivalent to 1/2. I can also check that by doing a picture. There's 3/4, and there's 1/2. And those are not equivalent to each other. Okay, so let's try another one. I always look for the little one, and I'm going up to the big one. I always look at my denominator first. What can I do to 4 to make it 8? 4 times 2 is 8. So is 3 times 2 really 6? And it is. That means these guys are equivalent to each other. I could also draw that model. There's my 3/4. I'm trying really hard to make them the same size on the outside. 8s, and I've got 6/8, and look at that. They are equal. Not equal over here. Try these two by yourself. Pause and come back. 2 times 4 equals 8, and 1 times 4 equals 4. So these are equal to each other. There's 1/2. And there's 4/8. Two different ways to show they're equivalent. These are already 8s, so I want to compare my numerators. Are my numerators the same? And they're not. 6/8 is greater than 4/8. That means they are not equal to each other. Okay, Jerry has 2 same-sized circles divided into the same number of equal parts. That's telling us that we have a common denominator. One circle has 3/4 of the parts shaded, the other has 2/3 shaded. So you have 3/4 and you have 2/3. His sister says the least number of pieces each circle could be divided into is 7. Each pieces could be divided into. Divided into is my denominator. So she's saying the smallest number could be 7. All right, so could 7 even work? Is there anything I could multiply 4 by to get 7? Or 3 by to get 7? Let's do our multiples. 4, 8, 12, 16, 3, 6, 9, 12. So actually, the smallest they could be divided into to be the same size would be 12. Jerry's sister is incorrect. I think that what she did was she added the denominators together. And you can never, ever do that if they're not the same size. That's not good math. All right, let's turn the page. Let's see, so we're on page 348. Let's do number 13. Carrie has a red streamer that is 3/4 yard long and a blue streamer that is 5/6 yard long. She says the streamers are the same length. Does this make sense? Now, if I look at the picture over here and I go from the picture, right away that doesn't make sense if I'm looking at the picture. What if that picture is off? So let's do it mathematically. Let's count by 6s. Let's look at our denominators. Count by 6. Count by 4. Stop when you have a common denominator. That's going to be 12. Okay? So if they're the same length, these guys are going to end up being equivalent. So 5/6 equals how many 12ths? And 3/4 equals how many 12ths? All right, well, if we get the same numerator, then we know that the streamers make sense and that she has the same amount. So 6 times 2 is 12. 5 times 2 is 10. 4 times 3 is 12. 3 times 3 is 9. So 3/4, 9 out of 12, is going to be a little bit shorter than 10 out of 12. So these guys are not equal to each other. So it does not make sense. They're not going to be the same length. All right, so that's kind of, let me do a couple. These are not in your, this next part's not in your workbook. My dog is ringing the bell. He wants to go out to the bathroom, so we're going to rush through the next part here. I took a screenshot, if I can get to it. There we go. Of a couple of your Go Math problems. So this is what your first couple are going to look like. First one looks like this. None of the others are just like it. Find the common denominator for 1/3 and 6/12. I like to write mine on top of each other. I think it's easier to look at than when we were doing it in the workbook. We want the same number of equal parts. See how 1/3, the pieces are bigger? So I can't compare those. I need that common denominator. The common denominator is. So this is not asking you to rename. This is saying, okay, take your denominators, get your multiples, and find the first one they share. So the common denominator is simply going to be 12. For that's the only problem on your assignment like that. It just wants the denominator. Now the next one is why I was writing your workbook problems the way I was. When you see these, you're going to enter the pair of fractions as the pair of fractions with a common denominator. So you're going to rename these two guys, and what did you rename them as are going to go in that box. So this box looks a little funny. You're going to tap in it, and then this little choice box is going to come up, and you're going to choose the fraction bar. That fraction bar is then going to pop in like it did on this one. And then that's where you're going to type in the top number, the numerator, and the denominator. And then the next box, you're going to tap on the box again right here. This is going to open up, and you're going to choose the fraction bar. Now, if you're messing around and you're having a hard time and you need to clear it, then you want to clear it with the trash can, and then it'll let you reset it and start over, okay? Because if you keep entering these little boxes, you're just going to keep adding them on top of each other, and it's going to be frustrating for you. So I have 1/2 and 3/4, and I'm trying to rename them with a common denominator. So I take my denominators, 2, 4, 6, 8, 4. Oh, didn't even need to keep going. I'm going to rename them using the denominator of 4. This one is already in fourths, so it's already done. I can enter 3/4. I'm going to rename this one so it's also in fourths. Whatever I did to the bottom, I'm going to do the top. So 1/2 is equal to 2/4. And then I type that in, and I check my answer, and it's going to show me that I'm right. Now, what you don't want to do is reverse these guys. If this one's 1/2, then its renamed fraction goes first. The renamed fraction for 3/4 goes in the second. If you reverse the order, Go Math is going to tell you you're wrong. The other type of problem you're going to see today is to tell whether the fractions are equal or not equal, and it's going to have a drop down. So remember, this one is more of a mental math you can do. How did I go from 4 to 8? Well, I multiplied by 2. Whatever I do the bottom, I do the top, and oh, it is 2. So this is going to be equal. You could also draw that picture. 1/4, 2/8. Okay? Now the picture isn't always going to be 100%. It depends on how well you draw it. Okay, guys, finish up. Staying on top of things. I know you can do it. Go ahead and do your IXL warm-up, and then do your Go Math 6-4.